Welcome to Understand the Math. In this video, I'm going to show you how to easily find the eigenvalues and eigenvectors of a matrix. The first thing that we'll need to do is to find the eigenvalues. We'll find the eigenvalues by first finding the determinant of a minus lambda I, and then we'll set the determinant of a minus lambda I equal to 0 and solve for lambda. To find the determinant of a minus lambda I, all we need to do is to subtract lambda from the main diagonal elements of our matrix A. Our determinant then is the main diagonal entries multiplied minus the off diagonal entries, which is 2 times 4, which is 8. We'll then multiply this out, and we get lambda squared minus 3 lambda minus lambda plus 3 minus 8. Combining like terms, we get lambda squared minus 4 lambda minus 5. Over on the right-hand side, I want to show you another way that you can do this for a 2x2 matrix. To find determinant of a minus lambda I, all you have to do is follow this formula. We get lambda squared minus the trace of A. The trace of A is the diagonal entries of our matrix A added, and that's going to be 4, plus the determinant of our matrix A, which is the diagonal entries multiplied, which is 3, minus the off-diagonal entries multiplied. And this gives us the same polynomial, lambda squared minus 4 lambda minus 5. This formula only works for a 2x2 matrix. For our second step, we're going to take the polynomial that we just got, lambda squared minus 4 lambda minus 5, and we're going to set it equal to 0. All we need to do now is to factor our polynomial. We have lambda minus 5, and we have lambda plus 1, and that's equal to 0. We'll then set both of these equal to 0, and we'll get lambda is equal to minus 1, and lambda is equal to 5. These are the eigenvalues of our matrix A. Now that we know what the eigenvalues of matrix A are, we can find their corresponding eigenvectors. To do this, we'll take a minus lambda I, augment it with 0, and then put it in reduced echelon form and solve for x. We'll then choose a value for the free variable. Let's find the eigenvector for our eigenvalue lambda is equal to -1 first. We have a minus lambda I, we'll augment it with 0, and then we'll plug in. We're going to subtract -1 off the diagonal, which means we're just going to add 1 to the diagonal. If we look at our matrix A listed here, we're going to add 1 to our main diagonal entries. So this gives us a 2 and a 4, and then a 2 and another 4, and we augment it with 0. Because our second row is a repeat of our first row, that row is going to go to 0. And then let's just go ahead and divide the first row by 2 to put it in reduced echelon form. This gives us a 1, 2, 0, and then a row of zeros. Let's now solve for x. We have a pivot in our first row, so that tells us that x1 is going to be equal to minus 2 x2. Our vector x is our vector x1, x2. And we're now going to plug in what we just got for x1. So this gives us a minus 2 x2 and then an x2. And then we can just pull out an x2. And that's our free variable. And we have a minus 2 and a 1. We now have to choose a value for x2. And I'm going to choose it to be -1. We could have easily chosen it to be 1. But I chose it to be -1 just so that our first entry in x is positive. And this gives us an eigenvector x is equal to 2 minus 1. Let's now find the eigenvector corresponding to our eigenvalue lambda is equal to 5. You might want to stop the video and see if you can work this problem on your own. Our a minus lambda I is going to be a with 5 subtracted off the main diagonal entries. So we have 1 minus 5, 2, 4, and then 3 minus 5, and we augment that with 0. This gives us the matrix minus 4, 4, and then 2 minus 2 augmented with 0. Notice again that our second row is a duplicate of our first row. You just take the first row, multiply it by -2, and you'll get the second row. So that means that row is going to go to 0. And then we can just take our first row and divide it by -4. And we end up with 1 minus 1, 0, and then a row of zeros. We'll now solve for x. There's our pivot, and that tells us that x1 is equal to x2. So our vector x, which is x1, x2, becomes the vector x2, x2. And then we'll pull the free variable out, and we're left with a vector 1, 1. The last thing we need to do is we need to choose a value for x2. I'm just going to choose it to be equal to 1 because that's going to give us a very nice value for our eigenvector. And that gives us an eigenvector x equal to 1, 1. Now you know exactly how to find eigenvalues and eigenvectors for a 2x2 matrix. This process will also work for matrices that are 3x3 or higher.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.